Hi everybody. Today we're going to be working on Unit 9, which is radicals, and we're going to be talking about Day 1 simplifying. So first let's talk about a little bit of vocab. If we see something like this, that is a radical, and what's underneath, what is inside the radical here, and also this symbol. So we're going to talk about some vocab here. So this symbol here is the radical. This item underneath here, so the thing that's being underneath the radical, is called our radicand. And the number that's going to go in the little radical symbol here is called our index. For the most part, we're going to be looking at an index of 2, and an index of 2 is implied. So if there's no number here, it's an implied 2. Just like when we did exponents, and if there was no exponent, we implied that it was a 1. We're going to do the same thing, but in here, it's an implied 2. So that's the first part with some vocab. The second thing that we're going to talk about is our list of perfect squares, because we're going to be breaking down numbers using perfect squares. So let's make a list of the numbers. We'll just do like 1 through 15 to start. I know you can't see the whole thing. I'll move my board down just a second. So if we're doing 1 times 1, that gives us 1. If we do 2 times 2, that gives us 4. And we're going to keep going down the line here. All right, so if we go 1 through 9, then we can see all on the screen here. So now we know that 1 is a perfect square of 1. 4 is a perfect square of 2. 9 is a perfect square of 3. 16 is a perfect square of 4, and so on. So let's finish our list. All right, so there are perfect squares up to 15. So this is the number on the left-hand side that makes the perfect square. But these numbers on this side are the numbers we're going to use in order to simplify radicals. So when we are given a problem, something like this, we're going to be using this property. We can break that down to be 2 separate radicals. So we can use this property when we are solving and simplifying our radicals. So let's do an example. If I gave you the radical 40, first we're going to look, is that on our list? So no, that is not on our perfect squares list. If we look, we have 36 and 49, but those are not on our list. But we can break this down to be a perfect square times a non-perfect square. So we're going to be looking for the biggest perfect square that divides into 40. So we could obviously use 36, 25, 16, 9, 4, and 1. Those are our only options because those are the numbers smaller than 40 that can divide into it. So we can divide these on a calculator. The only number that works out to be a nice whole number would be radical 4, and we know that 4 times 10 would still equal 40. So radical 40 is really going to simplify down to be 2. The square root of 4 is 2. That is on our chart here, times radical 10. So the simplified version of radical 40 is 2 radical 10. So in the future, moving forward, what we're asking you to do is to simplify these radicals, breaking them down using the perfect squares. So let's do some more examples here. And I'll leave that property right up there. So we've got radical 50. So again, we are looking for the biggest perfect square that goes into 50. Obviously, it cannot be 64 or any of the higher ones. So we're going to be looking at numbers starting with 49 that go into 50. Eventually, these things are going to start to become more second nature as you're working on simplifying radicals. You'd notice that this is, 25 times 2, right? We know that the square root of 25 is 5 according to our chart, so this turns into 5 radical 2. If we put this into a calculator, we are going to find that those are the exact same thing. So if you do 50, this radical 50, and you do 5 radical 2, you're going to get the same thing. So let me just show you by pulling out my calculator here. So the square root of 50 is equal to 7.07, all these numbers, right? It's not a nice number because it's not one of our perfect squares. But if I do 5 radical 2, that should come out to be the same thing. So again, we are changing what the problem looks like, but we did not change the value. And that's very imperative while we are doing these types of problems. So while you're working through these types of problems, you can check to make sure your work is right by doing just that. So let's do a couple more examples here. We'll do some bigger numbers. So let's try radical 128. So first we look on our list here. 128 is not on our list, but then we're going to be able to find the number that goes into 128. So what is the biggest perfect square that goes into 128? So maybe this is not going to be so obvious like it was in some of our last questions, so we're going to need to do a little bit of exploring. So maybe 128 can be divided by 64. Let's try that. And yes, that does work. This is the square root of 64 times the square root of 2. This multiplication symbol here is not actually necessary, but we know the square root of 64 is 8, and that gives us radical 2. Again, checking these on our calculator, we get that they have the same value, and therefore that means that they are equal. So all you're going to be doing for your homework here tonight is simplifying radicals. This is the type of work that I would expect to see, and obviously it would be really helpful to you if you have your list of perfect squares simplified down.